Today I'll be talking about my barbaric beginnings with this project. We'll move on to talk about the strategy I used for actually using SAS text miner, and finally I'll show you some of the results that I had with the final decision tree model I used. Starting off with just a basic visualization of the data set I was working with. This is in its very simple form. We're working with emails, so we had a subject line, the actual body of the email. Now these emails were coming into the company I worked for last summer. They were going into the customer support department. So the clients who emailed this company had a problem or a question or a request that they wanted to be taken care of from the company. So total time, the final column here, is the time in hours that it took for the time elapsed from when the client emailed the company and the client had his or her question answered, or the problem was fixed. I think you guys get the idea. So the beginnings, this project started when one of my coworkers came up to me with a data set of about 66,000 emails in it and said, "Hey Mitch, I want you to find the percentage of emails in this data set that relate to this specific type of problem." You know, and I was like, okay, let me get right on that, right? So what I did, I used a very crude, barbaric approach to this. I went through 1,000 emails on my own time, manually determined whether or not they related to the specific type of problem I was looking for. Once I had done that, I ran a frequency word counter. By the way, I'm going to go zoom through the slide for the sake of time. I apologize if you don't understand it. You can ask me questions later on if you want to. So once I had the 1,000 emails and I determined which ones relate to this specific type of problem, I used a frequency word counter on those emails. I then determined which keywords I thought would be best at determining whether or not the email fit into the category I was looking for. So whether or not that email contained that specific word, did that do a good job of predicting whether or not that email fell into that category. I ran a discriminant analysis to help me out with this. So looking at the scoring coefficients right there. The bigger the scoring coefficient, the better job it did at determining which category the email fell into. I then manipulated with the words that I had, took some off, added some others to kind of get the best model I was working with. This plot is kind of the final result from that. The blue dots represent this is just the 1,000 emails, 1,000 dots you see there. Blue dots represent the emails that actually fall into the category I was looking for. The red dots are all the other types of emails. And it's predicted on the canonical score, which is calculated by the scoring coefficients. Zoom through that, sorry. So the main goal with this was the company wanted to figure out if there was a high enough percentage of these emails that it would be worth investing time into figuring out how to do a more efficient way or to solve or prevent this problem in the future to ultimately save time in the long run. So I was thinking about this project, how can I save more time? What if I could not just look for a specific type of email, but predict an individual email, how long that would take, regardless of the category it was in, regardless of what it was talking about. And from this, I could determine which subject matter of emails took longer for this company. And you can determine, okay, do they take long enough that it's worth investing time in figuring out how to come up with a more efficient method to resolve these type of emails to ultimately save time in the long run. Introduce text miner, SAS text miner. It runs off nodes. Let's start by looking at this picture here. We start with our data set. This is the data set of those emails I showed you in the very beginning. It runs through the text parsing node. So all this does is like similar to a word frequency counter. It just counts the number of words that I was looking at. Text filter node is next. This does exactly what it sounds like it does. It filters those word frequencies, so it accounts for misspellings, it accounts for pluralisms, if that's a word. So you have like the word community and communities, it would count that as one word. It also allowed for you to import your own custom synonym data set and categorize whatever synonyms you wanted that related to this specific line of work in this company together. And I actually did end up doing that. I'm not going to talk about that though, for the sake of time. After it would run through the text filter, I ran it through one of these three nodes, the text topic, text rule builder, text cluster. I'm going to talk about text rule builder right here. It required a categorical response I was working with a quantitative response, my total time until resolution. So what I did was I created a categorical variable. I took the 75th percentile of total time. So I was looking for the top 25% of emails that took the longest amount of time. I chose this number because I figured, it wasn't quite as forgiving as 50%, but it also wasn't, as specific as 90%. I just figured it was, good middle ground. Because I wanted to determine, do emails take a long time? I figured 25% is a good number. This is kind of what the results look like for the text rule builder. It would create rules. Rules were composed of 1 to 3 words. If an email contained these words, the email would qualify for that rule. So let's start with rule number 1, actor. I do not know what this means. We call this like a junk or garbage rule. I ended up not using these in my analysis, but this is just for the sake of example. If an email contained the word actor, it would qualify for that rule. In my entire data set, 14 emails contain the word actor. 13 of those emails had a target value of 1. The target value of 1 meaning it is in that top 25%. 0 meaning it's in the bottom 75% of total time taken. So rules that I liked were, obviously this A tilde, that's garbage, that's junk. Investigating current, that's looking pretty relevant here. 13 out of the 16 of the emails with both those words in them were in the top 25%. Just an idea for how text rule builder works there. Let's move on to text topic and text clusters. These guys, the main difference between these two, an email can fall under more than one text topic. An email can only fall under one text cluster. Let's look at the text topics here. So text topics and text clusters, they can contain several words. They're not like a text rule builder, which only contain 1 to 3 words. These guys contain 5 words. They can also contain up to 100 words. If we look at topic ID 81 on the very top of the text topic output here, we can see 5 words that relate to that text topic. It looks like a pretty legit text topic that I would want to use in my analysis. It doesn't have garbage words such as para at Microsoft, a link in its description. Those relate to really kind of specific things going on in my data set that can't be generalized to emails that I want to use this analysis for. So looking at this one, emails that they don't have to contain every single word in these text topics, but they have to contain a good percentage of these words. And you can see 103 of the emails in my data set fell into that text topic. Text clusters are pretty much the same thing as text topics, but an email can only fall under one text cluster as opposed to falling under multiple text topics. The results output look a little different. You can just see I have the emails here, the subject line for the email, the description, and the number of the text cluster fellows here. As you can see, I have a lot of text clusters, 181. I think it even went up more than that. All right, do not be overwhelmed by this. I'll explain it. Let's look at the middle here, this little middle segment. So I ran two text liner node trails, one for the description body of the emails, one for the subject line of the emails. I wanted to look at both and combine them together, and I needed to run 2 trails to do this. This is the description trail, so it runs through that parsing, which is like a word frequency, filters out the synonyms and misspellings, and then I ran it through text cluster, a text rule, and a text topic. I did the same thing for my subject here. These 2 data sets are irrelevant. You can forget about those for the sake of this example. And let's see. So the output for my text topics and cluster variables, they worked really well. I was basically able to just output those and merge them together in the form they already were in. In terms of the text rule builder, it didn't work that way. I had to merge those together separately. So I would merge the text topics and clusters in this. This is just what's called a SAS code node. And you just open it up, it's just like SAS, and you can just code in it. And I would merge the text rule builders in this node, and then I would merge the merged text rule builders with my entire data set here. And I created this bad boy. Topics with rules, indicator 75, 2014. I started off with my entire data set, which ranged back to the year 2008, and eventually just worked out to 2014 because I found that email duration changed a lot over time, and I wanted to get the most accurate model I could, so I ended up just using emails in 2014. I ran, this is with the categorical response, so I ran a logistic regression and a decision tree with it. This is with the quantitative response of the total time quantitative variable. So I just ran a linear regression with that. I'm just going to talk about the decision tree right now for the sake of time, because that is the most interesting. Variables in my decision tree. 270 text topic indicators, 114 subject topic indicators. So text topics, indicator variable, 1 or 0. If the email falls into that text topic, it's 1. If it does not, it's a 0. Moving on to 270 description topic raw scores, 114 subject topic raw scores. In addition to having an indicator variable for a text topic, it also contained a raw score. These raw scores were how an email was determined if it fell into a text topic. So raw score, they range anywhere from like -3 to 3 based off just what I've seen. And if a raw score was high enough, like a cutoff value for that raw score, then it would fall into that text topic. I used 190 description. Again, I started really small with these numbers and just kept getting bigger and bigger to try and get a more accurate model. 190 description cluster probabilities. These are just the probabilities email falls into a cluster. SVD values, the very last one here. They stand for singular value decomposition. I do not know how the mathematics work behind these, but they're basically what are used to calculate the cluster probabilities. Over here I have my rules. So I basically pick and chose which rules I liked based on whether or not they were garbage or they had a high percentage of emails that fit into the category. I separated into tiers. So I had one top. These are my like best predictions. Pretty good predictions, but not so great for categorizing the one, the top 25%. Same thing with here, the 0. And I did them both for, these are the subjects on the bottom here. These are the descriptions. Moving on for the sake of time. This is what my whole decision tree looked like. Focus on a couple money makers here. 265 emails I was able to, after they met these conditions, sliding down on those different little tree nodes. 98.5% of them were classified in the bottom 75%. Only 1.5% of them were in the top 25%. It's a big moneymaker right there. This is another moneymaker for classifying the top 25%. Now the count's going to be lower, but remember we're just dealing with the top 25%, so that's expected. I was able to get 96.5 of those into this node if they satisfied these conditions. Final results, I was able to, in terms of predicting whether or not an email fell into the top 25%, I get 179 of those emails, 97.7% of the time being those longer taking emails. I did a mid-tier with these because it's just 25%. I figured, more than a likelihood of 2, or twice as likely more than that. I could get 232 of those emails, 62.9% of the time. In terms of my zeros, if they fell into the bottom 75%, I could get 99.1 of those in 465 emails. So all these emails that I was able to semi-accurately predict, if you will, they only represented 15.8% of my data set, which is not that much, but it's better than nothing. And that is kind of my presentation. I zoomed through that because I had a lot of material to cover. But yeah, thanks guys.
We have time for 1 or 2 questions.
Have you presented this data to your?
No, so next steps, I was basically able to just look at, if the emails met these conditions, they would, take a longer amount of time or not. Next step is to kind of just dig into those conditions. What do they mean? Can I figure out if an email meets these conditions, does that mean the email is talking about this specific type of problem? Once I can do that, I can go forward to the company and be like, hey, the emails with this problem, they're taking a really long time. Maybe you should figure out a better way to handle them. That's kind of the next step that I have not investigated yet.
And Mitchell, you tell us about your plan?
Oh, plans. So I will be moving to my parents' house in the Bay Area and searching for a job come summer.
What?